How would you like to charge your phone only once a week? Would you be more willing to buy an electric car if it could take you twice as far as it does now? How might your world be different if you could pay less for medicine? Believe it or not, all of those scenarios are in our reach. But to achieve them, we need to use electricity to power new chemical reactions. Most reactions that are driven by electricity happen in solutions of electrolytes. It's not quite the same as Gatorade, but it works in much the same way. Electrolytes are charged particles that help electricity move through a system. When we drink Gatorade, the electrolytes we consume help power our muscles. And when we do chemistry with electricity, the electrolyte solutions help power a device or a reaction. For many reactions that use electricity, like capturing energy with solar cells, we use water-based electrolytes. Most of the time, those work just fine. They're cheap, they're safe, and they're easy to make. But there's a problem. Just like how water will evaporate at high enough temperatures, it will also break down into hydrogen and oxygen under a strong enough electric current. That means we can't put Gatorade in our batteries, and we can't make medicines with Pedialyte. We'd end up breaking down water instead of making the products we want. So what can we use instead? Well, that's where my work comes in. As an electrochemist, I develop new electrolyte solutions that don't contain any water. Instead, I dissolve the electrolytes in a different liquid that's far less likely to break down, often the same types of liquids used in perfumes and cleaners. These water-free electrolytes allow us to do new chemical reactions with electricity. Perhaps the most tangible application of water-free electrolytes is in batteries. I've worked with a team to design new electrolyte solutions that could help us power research vehicles on other planets. But we draw on the same principles to power electric cars, trucks, and airplanes here on Earth. We could even use them to one day power our cities with renewable energy. And it's not just batteries. Using electricity can drastically reduce the amount of specialized and expensive chemicals that we need to make medicines. Our team has developed water-free electrolytes to recycle one such chemical, samarium iodide, which is used to make cancer treatment drugs and antibacterial products. With our new electrolytes, we hope to use 90% less samarium iodide to make the same amount of medicine. Water-free electrolytes will help us build a world where we can take a cross-country road trip in an electric car, where we never get stuck begging to borrow our friend's phone charger, where our lifestyles are more sustainable, and perhaps most importantly, where life-saving medicines are more affordable and accessible for all of us. Thank you.